I'm Divyanshu here, and today we are going to discuss about Coulomb's law. If you are a science student, you must have heard about Coulomb's law, and today we are going to discuss about it. The interaction between charged objects is a non-contact force that acts over some distance of separation between first charge, second charge, and some distance. The quantitative expression for the effect of these three variables on electric force is known as Coulomb's law. To understand the Coulomb's law, we have to start from the charge. As you know that the charge is present in every single body and in every existing particle. When you comb your hair, there is a charge. When you rub your hands in a woolen cloth, there is a charge. You are using a cell phone and there is a battery inside it and there is a charge. So we can say that charge is just everywhere, but everything does not behave like a charged body because the total charge inside it is electrically neutral, or we can say that the charge inside the body is perfectly balanced. Whenever any body loses its balance of charge, that particular body behaves like a charged body. With a very simple experiment you can understand it. Let us consider you are combing your hair and you must have seen that the comb gets charged and it attracts the small pieces of the paper. If it is attracting the pieces of the paper, there must be presence of charge. So now we can say that charged particle can apply force on each other, and that force can be measured with the help of Coulomb's formula. The Coulomb's formula, which states that the magnitude of the force between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. The Coulomb's law equation provides an accurate description of the force between two objects whenever the object acts as point charges. Now let us consider there are two charges, the first charge which is behaving as Q1 and the second charge which is behaving as Q2, and the distance between them is small r. Then the force between them will be F is equal of the K Q1 Q2 upon R square. In this equation, K is the constant of proportionality and the value of which depend upon the nature of the medium separating these two charges. The value of this constant of proportionality is 1 by 4 pi epsilon, and this epsilon is the permittivity of the medium. Now let us consider our particle are in vacuum or in free space. Then applied force between them will be 1 by 4 pi epsilon naught Q1 Q2 over R square. As you are looking that the epsilon is replaced by epsilon naught because the medium is changed to the vacuum. The value of epsilon naught is 8.85 into 10 to the power negative of 12 Coulomb square Newton meter square, and the value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9 Newton meter square Coulomb square. In general, the force is F is equal of the K Q1 Q2 over R square. This is the electrostatic force between the charged bodies, and if we compare the electrostatic force with the gravitational force, the mathematical formulation is analogous, but electrostatic force is a force between two charges separated by distance in space, while gravitational force is a force between two masses separated by a distance. Electrostatic force is either repulsive or attractive, while the gravitational force is always attractive. Electrostatic force arises due to influence of electric field on a charge mediated by photons, while the gravitational force arises due to curvature of the space by the presence of mass. So we can say that with the help of Coulomb's formula we can find the exerted force between the charges. If you want to know how it is decided whether charged particle is positive or negative, or how charged particle looks like, you can watch the video with the link given in the description. We will meet in our next video. Till that time, keep watching, keep learning, stay safe. Thank you.